Hi, good evening, everyone. Welcome back to PyData Pune events. Before moving to today's session, I would like to take this opportunity to talk about PyData and its mission. PyData is a non-profit educational initiative of NumFOCUS, which provides a platform to talk about things related to data. The aim of PyData is to promote discussions related to best practices, challenges, and new approaches for data management, processing, analytics, and visualization. Coming to today's agenda, we have a great talk for you titled as Experimentation with Papermill and MLFlow by Shadab. About Shadab, he is a full-stack data scientist and quantum computing enthusiast with around 3 years of experience in analytics and building end-to-end ML pipelines on the cloud using the Agile framework. He has experience in teaching quantum computing using Qiskit. He has founded and building the quantum computing India community. So without further ado, over to you, Shadab.
Thanks, Brian, for the introduction. Hi, everyone. Good evening. Thanks for joining the session on the weekend. I will share my screen. Let me know if you can see it. Is it visible? Yeah. Okay. So, starting with today's talk, very first, Mayank, is the session interactive? Like I can see the comment, or attendees can speak, or it's just like I have to present and then take up the questions at the end.
Yeah, you can like if there are any questions, then I can like those questions for you. And if you want, you can also go into the comment section, and there you can see the questions.
Sure. So before starting with the session, let's ask the attendees. We all are working as a data scientist, or many of you would be aspiring data scientists, right? And when we work in the production or with some real-time problems, there are chances like we have to run certain experiments with different models, and sometimes we tune the models with different parameters. We go for cross validation or hyperparameter tuning techniques, and then we also produce certain evaluation metrics and graphs for the reference. So this all become cumbersome, right, at the end, to keep track of each of the model we are training with different parameters, or each of the output we are getting in each case. Like for my case, like when I started with the data science, so if I have to do the experiment with certain data and I have to run different models with different parameters, I was running the same notebook and trying to change the file, CSV file in the same notebook, or renaming the notebook as like notebook one, notebook two, notebook final, notebook logistic regression. Such type of naming convention we used to use. And at the end, like not just that, but also like when you have to look for the graph, when you have to map certain outputs with the output graphs or output files, like suppose if you are outputting certain predictions as a CSV file, and for that CSV file we have certain ROC AUC curve as well for classification problem. Then in that case, keeping the track, mapping the outputs and all become quite hectic, and it was very much time consuming, right? So keeping that in my mind, keeping that in the mind, like I have aligned today's session so that we can understand how we can use some of the existing Python packages and tools for aligning this process and make our effort of running the models or doing the EDA or producing the output in quite efficient way, so that it doesn't take much time and we can keep track of each of these. Okay, so starting with this, so the talk title is Experimentation with Jupyter, Papermill, and MLflow. As the name itself suggests, we are going to talk about these three tools and how we can use that together in building the data science pipeline. Okay, so before starting, I will just give you the explanation about what is Jupyter, what is Papermill, and what is MLflow, and then we will pick up a data set for the demo purpose, and we'll see like how what was the process before using Papermill and MLflow, and how the process has been aligned after using these packages. Okay. So Jupyter Notebook, I hope everyone would be using. It is a IDE, you can say, like web-based IDE, in which you can code in 40 plus programming languages. So as a data scientist, we mostly go for Python, R, or few people use Julia also in the academic or research field. Okay, and then whatever code we are running in the notebook, we can see the output below the cell, and even we can share these notebooks through GitHub. We can upload the notebooks on GitHub or via email, or by uploading on Google Drive somewhere, or even the several other portals are also there, like Kaggle, Collab, where you can run this Jupyter notebooks, right? And Jupyter notebooks are mainly used to, I mean, whatever Python script we used to write in the Python file, the same way we can break down that script in different cells and can keep track of each of those outputs, like what outputs we're getting from each of these cells. So that if anyone has to reproduce those results, they can go and run the notebook with the data set and can see like what outputs they're getting. Okay. So if you want to learn more about Jupyter, what are the shortcuts and commands there, and how you can use Jupyter efficiently, so there are blog. I mean, you can refer official website of the Jupyter.org. They have good documentation, or else you can go to this blog towardsdatascience.com, in which I have tried to at least put up all the shortcuts, commands, and the extensions, which can ease day-to-day work of a data scientist. Okay, so uh, you can go to this link and just see like what all you want to take from there. Okay, coming to the Papermill. So Papermill is an open source package, and it is basically used for parameterizing the Jupyter notebook. So suppose I was talking about the problem, right? In starting, suppose if I've created a base notebook in which I'm doing some EDA, I'm building some base model, for example, logistic regression or decision tree or SVM, and then I'm using that model to make predictions on my test file, and then I'm trying to evaluate that model by taking ROC AUC curve and all, like whatever data science, whatever steps are involved in a data science project, I'm doing in that notebook, right? I mean, now after creating that base notebook, if I want to scale that notebook for different experiment, like forget about the experiment, let's talk about the data set only first. So here for this purpose today, I have chosen the stock pricing data set in which I have pegged certain stocks for which we are trying to monitor, like whether the stock is going up or down. Okay, just to give you a look of the data set. So these are the CSV files, right? For each of the stocks, we have different CSV files in which we have different attributes which we are using for training the model and for making the predictions. Right? So we have date. It is a time series data. The opening price for that particular date. What was the highest price the stock went for? What was the lowest price that stock went for? And what was the closing price? And then adjourned close, then volume. Okay. So this data set we are using here for training the notebook. So if I go to the notebook, very base notebook, suppose if we have prepared for this stock up down prediction, whether the price for the stock will go up or down. I will not deep dive in the like business understanding of a stock. Just try to understand like uh, how the notebook has been designed and how we are using Papermill and MLflow here. Okay. So very first, like I have considered S&P. S&P is like basically the stock pricing for the uh, largest 500 companies. Okay. And S&P stands for Standard and Poor's 500 Index. I mean, so like basically this stock pricing is for the 500 largest US publicly traded companies. Okay, so this data set I am using here, after loading the data set, for example, I am just going to use this much for creating some of the new attributes which I would be using further for training my model. Okay, so I'm creating some new features. I'm doing feature engineering here, like on by rolling the data set at the window interval of 2, 5, 10, 20, like that. Once I have done this feature creation, now I am trying to calculate the difference between the previous price and moving average. After calculating this, once we are done with all the, let me run and show you the code as well, how that basically looks like. So if you will see the data which I'm going to use further for time series analysis here, we have date, we have opening price, we have adjacent closing price, this thing, right? Now using the uh, previous price, like from here, what we are going to do is we are going to create moving average here on the interval of 2 days, 5 days, 10 days, 20 days, like that. Okay. So this will be done. Then obviously when you're taking the average, the decimal values you can see, right? It will go up to 6 digits, 7 digits, like that. So here we are just rounding off the values up to the 4 decimal points. Okay, and then here we are also based on the minimum period size, it should be 12 or 16 on that span of time. We are creating two more features, moving average 12 and moving average on the interval of 26 here. And then we are taking the difference of the previous price with the moving average. Then we have dropped certain of the attributes, like whatever feature engineering you can think of, we are doing here. After that, we have splitted the data into train and validation. So for 20 days, we are keeping like we are picking up 20 days data for validation, and remaining we are picking it up for training the model. Then there are certain utils files also we are using here for so that there are no unnecessary functions in the notebook, and we can just understand the flow here. So logger file is basically I have used to log certain artifacts, parameters, and all, which will be used in the utils file here. So in utils file, if you see, we have a function for plotting the ROC curve. We have a function for plotting the precision and recall. We have a function to save the model. This function is not like something which is saving the model by itself, but we are using MLFlow at the backend for logging the model and functions. Okay. Then this is the function for calculating the evaluation matrix like PUC, recall, precision, F1 score, and all. Then we have another function log MLFlow in which we will be logging all these parameters, artifacts, models to a particular directory. Okay, so you can see, right, if I talk about this basic structure, like we train the model. Now if I want to change the train validation split, or this graph which I'm producing right now, for that, suppose if this exponential moving average, if I want to change that time span for that, I mean, whatever features or parameters we want to tweak, then after a moment it becomes quite difficult to keep track of each and everything. Suppose if I change this to 14 or 15, like, suppose for example if I've created the features before, then oh, I've not run this before, right? Let me run all of it. Okay, then it becomes quite difficult, right? Like how to which plot was for what moving average label, where it has been logged, how my data set was being created there. So to align all those process, we have Papermill, in which we can pass all the parameters required uh, in the notebook, and then it will automatically create the output notebooks, and it will pass all the, it will iterate through each of the parameters which we want to pass to that notebook, and it will uh, log that notebook at the output directory, whatever we will specify there. Okay, we will come to that part as well. Then some of the feature transformations, whatever we have done here, because the feature was not scaled right. Some of the values would have been very high, some of the values would have been very low. So we have done certain feature scaling here. Then I have not tried using the efficient way of time series data prediction. I'm just using some basic machine learning model to not dive deep in the machine learning side rather than just focus on the data science process, like how we can improvise that. Okay, so we have trained linear regression model here, and certain metrics we have got. Right, like if you see the R square adjusted R square value, the value was close to 0.97, and then if you go for logistic regression, then if you see here p values, so for most of the columns the p value was quite lower. Then we have calculated certain evaluation metrics, right, precision recall and all. So these values we have plotted here in the notebook, right? Like if you see, this is the ROC curve. This is showing how it is moving. Then this is the precision recall curve, like how the values are moving at each of the interval. Then like that, we have trained several other models as well, SVM, key enablers, and then gradient boosting model we have trained, and back trees, right? So if this thing I have to just do for one of the stock SNP, because we cannot combine the stock data in a single CSV file, right? Each of the stock behaves differently in the market. So if I'm going to combine all these CSV files, so like whatever I have in the data directory, that will not give me the right model. So for that, I have to treat each of the stocks separately, and I have to train the model for each of the model for each of these stock and deploy that in the production, for example. Okay, so that's why we need separate notebooks here. So and for separate for different stocks, there will be different notebooks. And if I'm just keeping one notebook, or if I'm just rename this as a new notebook, again I have to run all the five notebooks separately, one by one, right? And monitor all the outputs, create the folders manually for logging those artifacts or metrics, and even these precision recall value. I mean, plots and all we can save to the directory wherever we want, but getting all the details at one place won't be possible, right? I mean, we cannot see some kind of dashboard where we have all the metrics, we have all the parameters used for training the model, or the curve, how the uh, plot is moving there for simple moving average and for comparing the results, right? So, coming back to the presentation here, like Papermill basically eases the task of parameterizing the notebook. So, in this notebook right now, I have just this is the base notebook, which I will be running further with the Papermill notebook, and I have just parameterized the index here, because for my use case, other than the index, nothing else is changing, right? I just have these five stocks. Each of the stock names I will be passing one by one. Based on that, the data file will be picked up from my directory, and model will be trained and logged. Okay, but use case to use case, you can parameterize whatever you want. Like we can even suppose if you are dealing with some retail data or some marketing data, then there maybe you would be interested in the data of a particular month or particular year. Then even you can pass the year also as a parameter. You can pass the month as a parameter, or if you are just interested in looking for a particular like in retail also we have several subdomains, right? Like groceries is a separate entity, like people treat that separately. The online e-commerce websites data, like I mean, if it is a live sale or some flash sale is going on, then the behavior of that data will be different. Then such kind of parameters you can parameterize and run your experiment. And even the model parameters also you can parameterize here. Like suppose if you're training the model in the you can either do in the notebook itself and train the model for different parameters, or if you want to parameterize that from the paper mill notebook, that also is possible. You can just pass like what all parameters you want to keep. I mean, you can create a structured way, like in a dictionary, like this is the model for this model, these are the parameters I want to tweak in, like that. Or if you're using cross validation or other hyperparameter tuning techniques, then that might be not needed to parameterize, but the logging and keeping track of those parameters becomes very much important there, so that you can see like which model is what accuracy or what precision recall values I'm getting for which set of the parameters there, right? So all these things can be done using, I mean, for logging and tracking, we have MLFlow, but for parameterizing the notebook, we have Papermill. If you're interested in learning more like what all functions and features are there, I will just cover up the basics part so that you can get it started with this. Might be many of you would be already using that in the production. But if you want to learn more, you can go to this documentation link and can see. Then this is the base architecture which I have picked from one of the blogs available online. So basically, we have the source notebook, right, which would be loading data from some database or from some file or by connecting with certain kind of services. Like if we have once we have the data in the notebook, then we process. So this notebook will be picking up the data, right? And whatever parameter values we have, that we will be passing as the input to that notebook here. Okay. So in our case, the parameters are the different stock names which we will be passing here. Then all these will be put up in a Papermill notebook, and Papermill notebook execution goes in that way. Like one by one, it will run the notebook for each of the input parameters. It will execute the cell. It has a runtime manager and runtime process which monitors, which create a copy of this input notebook with the input parameter. It completes the execution of that notebook and output that notebook to a particular location, whatever output path we will give. Okay, so this is how the base architecture of Papermill notebook will look like if you're using that. Okay, so it some of the pros of using this is like you can automate the execution of your notebook. You don't have to sit and execute each of the cells of the notebook or different notebooks manually. There, you can just pass in the name with different parameters, and the execution will be automated by using Papermill there. Outputs will be immutable. Inputs also, whatever will be passing, will be immutable. And obviously, the very important part is the parameterization. So this, I mean, as we dockerize the Jupyter notebooks in the production, right? The same way you can even just install the Papermill also as a package by using the pip command, pip install Papermill, and you can use that in your Docker container or in your deployment environment as well. And the whole basically the whole execution can be also integrated with the GitHub as well. So if you have aligned or designed some of the process in the production for your clients or something, you can just clone that repo and just make sure like whatever commands you're running from there, the path and directory should be aligned with the GitHub structure after taking that copy in your Docker image if you are using that, if you're going that way. Okay, so there you will be giving the relative path, and you have to maintain a certain folder structure to make sure that you're not missing any files or you're not giving the wrong notebook paths and all. Next, coming to the MLFlow. So MLFlow is an open source package developed by the Databricks team, I think, and it helps in keeping track of the experiments by logging the artifacts. By artifacts, I mean the charts or plots, whatever we produce from our notebooks. By saving the model, it has, I mean, quite. It also supports TensorFlow, PyTorch model, and even PySpark's model as well. So you can log and reload the trained model and make the predictions. And also you can compare the, I mean, whatever parameters you have used for training your model, that also you can log. Whatever output you have got for the evaluation metrics, that also you can log. And these all details will be logged along with the date and experiment name, so that it becomes quite easy for us to track the whole process, whatever we are doing. So you don't have to sit and monitor your notebook. You can just go to the dashboard and see, so stock up down, this is the experiment name here, and this is the user who has run this. So it will also display the username, it will display the source, how the, basically how the, you can say, from what source the data was being run. Then for what, so I was talking about the stock, right? So you can also, whatever price you are giving, input I have passed from Papermill to the input notebook, and the from the input notebook to identify each of these outputs for me, like what output is for what index or what is stock price. I have logged this also as the parameter, like for what parameter, for which model, what was my AUC curve, FN value, or precision recall value. Okay. So any doubts so far, Mayank? I mean, any questions in the chat?
Not yet, Anshul. No
Okay.
questions.
Okay. So if you are facing any doubts or questions, right, you can directly just ping in the chat. I can pick up in the middle as well. Moving forward, so it has basically MLflow has basically four components: MLflow tracking, MLflow projects, MLflow models, and MLflow registry. So MLflow basically, as I told you, like it is an open source package which anyone can use, and it is very much helpful for managing the life cycle, for reproducing any of the results, for deployment of the model in the production, and even for doing the version control also you can use MLflow. So I will show you like how the version controlling has been done in MLflow, and you can like whatever ideal model you have got, like suppose five models you have trained with different parameters and different kind of machine learning techniques you have used for that. Now after going to that dashboard, you have found that XGBoost or gradient boosting tree is performing best. So that model you can register from the UI itself. I mean the code, you can do that from the API call or using the Python code also, and then that particular model will be used for making the prediction. So you don't have to really map, you don't have to even care of like which model I have to pick, how to put that I mean how to use that model from the notebook and use that for the prediction like that. Okay. So talking about MLflow tracking, right? So MLflow tracking is basically an API which I mean using which we can log all the parameters, artifacts, the I mean the evaluation metrics, whatever we are getting out from those models, any output files if it is getting produced, whether that is in the format of some CSV, Excel file, or PDF file, or HTML file, those files can be also logged, and even the machine learning model you can also save using the MLflow tracking server. Okay. So right now, MLflow, these login things you can do using Python or REST API or Java API, or even they have support with R as well. Okay, so mostly in data science we use Python and R. So both of these languages are being supported by the MLflow API. Okay, and suppose if you're designing your own web app, then you can even go for the REST API as well. Okay, so if you're running these experiments for your own, then you can build the app locally, or you can just track the experiments from the notebooks, or even you can deploy the ML flow on some cloud like Google Cloud or AWS or Azure or whatever cloud services you are using, and you can output the results to the UI. So if you're running that job in the cloud, right, then you just have to make sure that you have configured the ML flow and you have designed, I mean, you have given the artifact path and model logging path and the artifact tracking paths, these two, three things properly on the cloud. Like you can, suppose if you're using Google Cloud, right? So you would be storing those artifact files and model files or the logging, whatever parameters you're logging, uh, somewhere on the cloud only. For example, like we can use GCS, Google Cloud Storage Bucket there, right? So you have to make sure that the bucket which you are using, you have the access to it, and the path which you are giving for that particular experiment is proper. Then you can even do automatic logging. So I mean, like right now in this base notebook, whatever I have done, I am logging all the parameters and all manually. Okay, but MLflow also supports the automatic logging with most of the commonly used machine learning packages, right? Like for example, if I talk about it, is it can be scikit-learn, Spark, PyTorch, FastAI, XGBoost, and few others as well. Okay, so if you're going for automatic logging, that also option is also there. You just have to uh, create the experiment, and certain code will be there, which I will be showing you in some time, and it will be done. You don't have to manually go and log the experiments, parameters, and all. It will be logged automatically. Okay. And the output will be, you can either display via UI, or you can, if you're building your own website or web app, you can display it on some web server. Next is MLflow project spec, right? So in this, like whatever we have discussed so far, that was just like things was quite spread. Right? Once we are done with the experimenting and all, we want to package each and everything, whether it is code, whether these are dependencies, data, or any of the configuration in a particular project format, right? So MLflow projects basically packaged all the data science code in a reusable manner, so that if you want to run that project later on with some other parameters, or if you want to tweak certain things in the Papermill notebook parameter to be passed to the input notebook, you can do that. Or even for reproducing the results, you can package all the things, right? So how do we manage the data science project? Whatever we do in the starting phase, we explore the data, we build the model and all. Once we have finalized, like, okay, these are the dependencies, this is the code, this is the data I need, this is how I'm going to process the data, everything will be packaged on in a uh, packaged as a project and deployed in the production, right? So the whole these things can be taken care by the MLflow project spec as well, MLflow projects also. So that execution either you can do locally, or if you are using some cloud, you can do the remote execution as well. Okay, so basically some of the features if I talk about for MLflow projects is like you can reproduce the results, you can do the iteration on these projects very quickly. You don't have to like go and dig in each of the files separately. Okay, yeah, and environment and also like will be very much aligned with the code, whatever you're using. So you can just specify each and every package what you're using in dependencies, which will be taken care of. Next is MLflow model format. So like in data science lifecycle, after doing the idea, we train the models, right? And we need to package the model and put that in the production in real time, or else by just doing the analysis, if the model is not in the production, it doesn't make sense there. So MLflow supports different uh, libraries and packages. As I told you earlier, TensorFlow, Scikit-learn, R, Spark, and many more. So the run source can be either locally, or you can run it from notebook or from some cloud. And then all these models, like whatever model formats you're getting, you can store that in a directory. And by using the model registry or model versioning support from the MLflow, you can put that in the production. Okay. So for instance of the code and all, if you're using, you can use Docker and Python for deployment. If you're doing some batch or stream processing, you can use Apache Spark and all. And there are several other serving tools as well, like Kubernetes you can use and all. Okay. So just to tell its capability, like it supports so many different kind of models which you can deploy to the production or use like the way you want. Talking about next, we have model registry. So model registry is basically so we have to nowadays in data science. I don't know how many of you are doing. ML ops is in limelight, right? Because earlier at the earlier stage of data science, people were training the model, but they were not very much efficiently deploying those models or maintaining the CI, which has become very much necessary steps for all the data science project and industry. Most of the industries have been adapting the CI/CD pipeline as well, right? So even you can integrate the CI. I mean, you can use model registry for, I mean, model developer as well. You can build the model and put that model. You can register that model and call that in the production. And even it can be used by the users and CI/CD, the person with maintaining the CI/CD pipeline as well. Okay. So using MLflow model registry, certain like which model to put in the production, you can decide certain threshold based on any of the evaluation metrics, or based on, suppose if you want to put the latest trained model in the production, if you are training the model on the daily cadence, then all these things can be taken care by the MLflow model registry. So you can automate the jobs, you can do the rest surveying, you can downstream the users. Okay, I think this was the last slide. Okay. So coming back to the demo part, right? So I have shown you the base notebook. What we are doing, we are just doing some feature engineering. We are calculating moving average, and we are calculating exponential moving average based on certain cadence, based on certain time span, and then we are training the model. We are seeing like uh, how the price, simple moving average, and exponential moving average vary. Then we have done certain feature transformation. After training the model, we have logged. We are using that model for the prediction and doing checking on the evaluation metrics, and by plotting that on the graph, right? So let's come to the architecture. So suppose if I have to do this for different stocks, I have to change the stock name in the starting, then for the another stock, then again change, then for the another stock, and so on. And obviously, if I'm doing that, uh, I will lose the output of the previous run experiment, like whatever the output I got for the previous stock, I will lose that. Or another way is like I create 5 copies of this notebook and save it as like stock up down base S&P, stock up down base nickel, like that. So again, the problem there is like I have to go to each of these notebooks separately and I have to run the notebooks manually there. Okay. Now see like how the this is the parameterized notebook. Okay, I will first show you like what new I have added to the parameterized notebook. Okay, and after that I will take you to the paper mill notebook, how the output will be executed. So very first thing, if you are parameterizing the Jupyter notebook for the paper mill, you have to tag the cell as a parameter. Okay? So if you see the paper mill notebook structure, in this I'm just importing the paper mill and loggers file which I created, which I've shown you earlier. And then just with 4 lines of code, if you say this code, these are my parameters, right? All these 5 different stock prices. So for all these different 5 stock prices, I am going to run my input notebook and I'm going to output that output of this input notebook in this artifact directory in the notebook folder, and I'm appending the index name so that I can identify each of those output notebook uniquely. Like suppose if it is running for S&P, the output notebook name will be stock up down S&P. Like that, it will be getting saved at this output path. Okay. So after importing the package, if you see, I'm just using pm dot execute notebook, papermill dot execute notebook. You have to specify the input path. Input path is basically the path of the input file which we have parameterized. Then output path is the uh, like name of the output notebook along with the directory. The same way you have to specify it. And I am parameterizing this so that I can identify each of these stocks uniquely. And what is the parameter? So you can see, right, I am passing the parameters here. So these parameters you have to specify in this input notebook as a tag, so that when it passes the parameters from the papermill notebook to the input notebook, it can identify in which cell I have to inject those parameters. If you will not specify, then also it is fine, but then in that case it will just inject in the starting of the notebook. Or else, if you are specifying the parameters tag here, it will inject just below this cell. So how do we basically specify the tags, right? So if I talk about tags, you have to go to view, cell toolbar, you have to go to tags. If you will select that, you can see you will get this kind of option on I mean on top of each of the cells. Here you can just enter the tag name, like whatever you have given. So in my case, it was parameters. Right? If I will remove this, I have to just enter parameters. You can click on add tag or just hit enter. This cell will be tagged as the parameters tag. Now, when I will call this notebook from the papermill notebook, right, it will be knowing like to which cell this parameters needs to be injected, and to that particular cell only the values will be injected, and further processing or further execution of the notebook will be done. So in Papermill, you can see, right, nothing else I have done. I'm just importing and just passing the parameters one by one. While calling the execute notebook function, I'm just specifying the input path, output path, and parameters. That's it. Then in this, these are the same thing. You have to specify the experiment name, which we will be using in the MLflow, the run name and artifact directory, where you want to store your output files, or where you want to store your artifacts, models, graphs, and all. So these all I have packaged as a dictionary so that I can just access each of these values from the dictionary one by one. And then you can see here, right? I have parameterized the data loading path by the index name. So one by one, when this notebook will be called from Papermill for different parameters, it will just replace the file name here, and that particular data will be loaded. Then certain pre-processing has been done. Uh, Same thing we are doing. We will be training the model, different model site, and whatever summaries we are getting. Then after that, we start the path of uh, the important path where we are going to log these files to the uh, to the MLflow server. So right now, because of certain changes in my system, I'm getting this error. It's not able to access certain directories in my path, but I have saved the output here on the Jupyter's notebook. So I mean on the GitHub. So let me show you how it will look like. It's taking time. Alright, let me do that. Okay. So in log MLflow, if you see, I'm passing the run params, right? Log MLflow is not the function which is coming from the MLflow. This is the custom function which I have defined in the utils file. Okay, and if you go to the top of the notebook here, you can see I'm from utils. I'm importing log MLflow and evaluate binary function. The evaluate binary function is basically used for calculating the evaluation matrix, and log MLflow basically to log all the artifacts and whatever things you have to log from the to the MLflow server. Okay, taking you to the log MLflow function in detail, we need certain parameters here, path, the model name, then y to y prediction for calculating the uh, certain evaluation metrics. Okay, so in this, if you see, like I'm calling the evaluate binary function to get my ASC, recall, precision, F1, because these I'm logging as the output here. If you can see the dashboard, you see F1, precision, and recall. Just let me. Okay, and yeah, coming back to this part. And then I'm also plotting precision recall plot, and then I'm also defining the path where the model should be saved. And then this is the main function of the ML flow. Like you have to start the experiment run, pass all these parameters, metrics, and artifacts one by one to be stored on the server. So in param, basically we pass the parameters which are being used to train the model. Okay, so if you see, I'm passing log para model name. So in model name, basically we am passing like what is the model name for which this experiment was being run, and what was the index. I'm not logging several other parameters here for now, but if you want, you can log the different parameters as well. Like for example, if I show you the logistic regression, stats well model we have logged, right? Linear regression is here. So suppose if we want to specify any of the logistic regression or linear, I mean whatever model you are training for that, if you want to specify any, if you're changing any of the parameters also, and if you want to log that as well, you can log in the parameters tag. Okay. So if anything that is related to the training of the model, that will be logged as a log param. The evaluation metrics of the model gets logged under the log metric, and the artifacts like plots or charts and the model, those gets logged under the log artifact. Okay, so if I open any of the experiments which I have executed before, you can see, right? In parameters, I have not specified any of the model parameters. That's why it's not showing. But in your case, if you try to look at that as well, you can specify here. You can see the parameters. You can see the matrix I have logged. You can see, okay, artifacts has not been logged. It seems for this. So, all right. So in case of artifacts, it even shows the artifact as well. This experiment I feel. Let me see. It's not able to access the artifact directly because of some permission issue. But if you are going to clone that trapo and run, right, then it will be showing to you. So if I go to the, if you want to compare the results of any of these metrics, you can select and like whatever metrics you are interested in. Then you can even log scale the y-axis as well and plot the values. I doubt if we have control over selecting the type of the chart here. Yeah, but I mean, you can even compare different metrics as well. And also, there was one more thing like, let me show here. Okay, right now, like I'm not getting that option, but even you can select the type of different graphs as well. Like two or three options are there on the MLFlow, which you can go and explore with. Okay, so coming back to this function, like this, you can log all these parameters for different iterations. And yeah, so like this is what I'm doing for each of the models which are getting trained. So now you can see, right, I don't have to go and sit with the notebook and monitor the results. Everything will be taken care by the combination of Papermill and MLFlow. Papermill will automate my execution for different stock names, and MLFlow will help me in logging and monitoring the outputs. Then you can even use MLFlow to load the model which you've already logged, and you can use that for making the prediction further. So this is for now. Let me show you certain more things. So if you want to run this, right, you can just clone the repo and all the steps I have specified here, like how you have to clone, how you have to change the directory and install dependencies, how the IDs you will get, how to start the MLFlow server. Okay, and so this is how your MLFlow server will look like. And talking about uh, CSV files and all, yeah, this is so that's it from my side. So this is how we align all the process using Papermill and MLFlow. So any questions now? And certain links and slides I have given at the end of the slides. If you want to go through them for Papermill or for MLFlow or Jupyter Notebooks, you can just refer this and can do. And if you want to deploy deploy these models on MLFlow server on Google Cloud, then for Google Cloud platform, I have written a blog. You can go and check that. For other servers, steps will be more or less will be the same, and you just need to configure the Nginx server there so that link can be accessed outside. Okay. So if you want to get connected with me, you can connect with me on LinkedIn or Twitter. Thanks for attending the session. Let's get back to the question.
Yeah, Shadab. So I think that we right now we do not have more questions. We do not have any questions as of now. So people will go through it and they will connect with you if they have any question.
Sure. How we can share the presentation link, Mike, with the attendees? I can
Yeah.
post in the
So
chat.
yeah. So you can like post. You can send them to me and I'll append them in the video description in the YouTube.
Sure. Then I will send you the presentation link, GitHub link, and the yeah, that's it.
Sure. So if you want, we can wrap it up.
Yeah, we can wind up there. If you don't have any questions.
Yeah. So Thanks, Shadab. We are very grateful to you for sharing your time with us. Thanks a lot, everyone. This talk shall remain on YouTube. Thank you once again, and hopefully we connect with you soon.
Yeah,
Thank you.
thanks for hosting the session. Thanks everyone for attending and bearing forward.